Hello everyone, in my hand I've got a past paper from the SQA. It is Advanced Higher Mathematics of Mechanics 2022, and I'm going to do the first two questions on this. As you can see, the paper, it's here. There are 16 questions to be completed in 2 hours and 50 minutes. I'm only going to do questions 1 and 2. This past paper and the marking scheme is available on the SQA website. Here's another document, the specifications document. This tells you all about the course, including content, and that's also available on the SQA website. Teachers need this document to cover all the content necessary, but it's a good idea for students to have it as well, to see what's been referred to, and you can do your own research as well as you're going through the course. Now there are 3 overall themes in this course: forces, energy, momentum, straight line, periodic and parabolic motion, and mathematics techniques for mechanics. All that will become clearer as we go through it. These areas. The course also looks at 12 particular skills and knowledge in these particular areas, and you can stop the video anytime you want to look closer. But for the first 2 questions, we're dealing only with a momentum question and a partial fraction question, as we can see. Now, question 1A is a relatively straightforward question just to get us started. We've got a 8 kilogram object being pulled by a 65 Newton force, being pulled or pushed for 1.2 seconds, and we're asked to find the final speed after that. Now, it's on a smooth horizontal surface. That means we can ignore friction and we can ignore the object's weight. Remember, weight and mass are 2 different things. The 2 expressions we'll use, you'll find in page 6 of the specifications, are F equals ma to find the acceleration, and once you've found the acceleration, multiply that by the time to get your final speed, which is 9.75 meters per second. A very straightforward question, just to get us started. Question 1b. Now we're told our block's going along at 9.75 meters per second. It strikes the wall and it rebounds with no loss in energy. Now we can take that to be, in this case, no loss in kinetic energy. Therefore the speed at which it hits the wall is the exact same speed at which it retreats from the wall, 9.75 meters per second. We are asked to find the magnitude of the impulse. Well, impulse is equal to F times t, where F is the force the wall exerts on the object and t is the time the force was acting for, and we don't know neither of those things. So we need to find another way of working this out. Now if we look at page 4 in the specification sheet, we can actually see our top expression I've highlighted in orange. Notice everything in all the letters that are in bold are vectors. So what we have to do here is we have to find the change in momentum as a vector, then find its magnitude to give us F times t. Those are the equations on the right. Those are the expressions, I should say, on the left and right. Now if you notice this question, no directions at all are mentioned in this question about direction. Therefore we need to decide what our own direction shall be, and as usual we just take to the right to be positive, and anything going to the left has got a negative velocity, and we put that into our expressions, and we get an answer of negative 156 Newton seconds. But the negative is referring to the direction. The direction of the impulse is in the same direction as the change in momentum you would expect, and it is. However, we just want to find the magnitude of that, which is 156 Newton seconds. And what does 156 Newton seconds mean? Well, it can be 156 Newton force acting for 1 second, or it can be a 1560 force acting for 1/10 of a second, and so on. Question 2. Now we're given an expression and we're asked to write that expression as a sum of partial fractions. That can be convenient and it's an important technique. How do we do that then? Well, we have to know what the rules are, the decomposition rules. This means this. Let's look at page 32 on our specification document, and it says this. It invites us to look at the denominator of our expression, and it then invites us to look to see if there is any distinct linear factors or repeated linear factors, and we've got both. We have got a distinct linear factor, and that is 1 plus x. So that gives rise to its own partial fraction, some constant divided by 1 plus x. But we've also got a repeated linear factor, and that is a 1 minus x. It's 1 minus x all squared. So it's squared, so we've got two of them, so it's repeated. Now that gives rise to two partial fractions in our answer. It's our job now to solve these expressions, solve that expression for those three constants. Now to solve this equation for a, b and c, we deal with it as a normal fraction. For example, we cross multiply, we cancel where it's possible, we expand the brackets, we multiply out the brackets, then we gather coefficients, then we compare the coefficients to set up simultaneous equations. So we've got our three simultaneous equations and we solve them to get a is equal to 1, b is equal to 2 or c is equal to negative 1. Thanks for watching the English College Physicist, and I will provide the answers for another couple of these questions in this exam paper very shortly. Thanks very much.